Hello everyone, I'm Brandon Ordonez from ECE 31 and today we're going to perform our summative assessment number 2 for our Power Electronics Laboratory. Brandon's Vlog. Let us proceed with our summative assessment 2 for our Power Electronics Laboratory. So the problem is, a half-wave rectifier has 120 VRMS 60 Hz AC source. The load is 50 watts. Determine the value of a filter capacitor to keep the peak-to-peak ripple across the load to less than 1.5 volts. Determine the average and peak values of the diode current. So initially, we need to determine the values of our resistor and our capacitor. The values are gained through our computation section of the paper. So first, let us simulate using Multisim for a quick checking. So we would need an AC source and a diode, a capacitor, and a resistor. Also our ground. Now connect the circuit such that the capacitor is in parallel with the resistor. So the computed value for our resistor is 576 ohms, and for our capacitor it is 3.27 millifarad. The value of capacitance for our capacitor is 3.27 millifarad as seen from our computation. So let us run. First, before simulating, change the peak voltage rating to a very high value, so that the components of the circuit would not burst. So we need to measure the power across the load, which is supposed to be 50 watts. There, it is 49.4 watts. Then let's measure our current flowing through the diode. There. From here, we can see that it is still 60 Hz and the average DC current is 294 milliamperes. So it is recorded here in our paper. Next, let's open OrCAD for our PSPI simulation. So we would create new project, analog mix summative 2 for title and for the location. There. Yes. Open the first page, then build your circuit. First, we would need a source, sinusoidal source, and then we would need a diode. Then our capacitor, then our resistor, and our ground. Now connect the circuit. Okay, so now change the V off to 0. The amplitude should be 169. 169.7 since 120 times square root of 2. Next, frequency 60 Hz. AC change to 0. Diode should be on D break, and this should be 3.27 milli. Then our resistance should be 576 ohms. There. Check. 3.27 and 576, 0, 169.7, 60. There. Now, create a simulation profile. For here, we would use 100 seconds as the runtime, since the capacitor would require a longer period to have a steady state. Apply. Okay. Then click run. Then wait for PSPI to load the circuit. Then after simulation is loaded, add trace. First, we would look at our current, diode current. So for us to be able to zoom in, as now we can see that it is steady. So let's zoom in. There, you can see that the current peaks are almost same in value. So measure 1. So our recorded experimental diode current is 11.109 amperes. Next, delete. Then check for the average diode current. There, we could see that first it has an offset. Then, if you would look at the values at Y1, the average current value would decrease over time. Therefore, we should not measure after one period since it is not yet steady. So here, around the 60-second point, the average current is observed to be steady in value. So here we could see that at the end of the 100-second point, it is 296.284 milli amperes. Since this is our steady state value for our diode current, we would use this value as our experimental value for the diode average current. Next, so the values recorded can be seen here. Next, we should check the ripple voltage. The ripple voltage can be checked by looking at the R12 there. Since it is observed to be steady, let's zoom in anywhere. There. We could observe the ripple voltage by the difference of the highest point and the lowest point. So the ripple voltage can be observed here at Y1 minus Y2. It can be seen that the ripple voltage is 1.3974, which is less than 1.5 volts. Lastly, we could try to get the power. So click average and power across our resistor. Zoom out. There. From here we could see that the power is at a steady state. It only has few differences across each point, but it is considered nevertheless steady since it only has minimal changes in value across time. So at the end, you could see that the average power is 48.711 watts. Therefore, it's close to 50 volts. Not only at the end, but anywhere here, the value is close to 50 watts. If the value does not exceed 48.7, it only remains within the 48 to 49 watts point. Here, there is a slow increase in power because of the capacitor charging. There. So, again, to recap, this is our multisim circuit and simulation, while this is our ORCAD circuit. Our simulations are recorded. First, the peak diode current measurement at steady state is at 11.098 amperes for the peak diode current. Next, average diode current value is recorded at 196.284 milliamperes. We have recorded the value at between 60-second point to 100-second point because it is where the current is steady. Since from 0 to 60, the diode current slowly decreases. It can be observed that through time, the diode current slowly decreases. The average diode current slowly decreases and is steady at the 60-second to 100-second period. Next, the ripple voltage value is 1.4076. From our simulation earlier, it is 1.39, which is also a close value. Since these simulation records are recorded earlier, it has a slight difference in value, but it is close nevertheless. So the ripple voltage is measured from the peak to the maximum point of our output voltage to our difference with the minimum point of the output voltage across the resistor. Therefore, again, the ripple voltage is 1.4076, which is also less than 1.5. Lastly, for our average load power, we could see that the power waveform is steady here at 48 watts. Therefore, our recorded experimental value for the average power across the resistive load is 48.68 watts.